So my name is Erik. I come from a company called Wise, and our mission is to remove borders in the world of finance. So in geographical world, when people travel, there are a lot of restrictive borders. So you need to have passports and you need to have visas. So we want to make sure that in the world of international finance on a cross country level, people will always feel like home wherever they happen to be. And probably could be talking about a lot of stats about the company, but I prefer not to spend too much time on that. We'll just focus on one particular stat. It's that today, out of all money that is transferred across borders in the world for the consumer market, $1 in any currency equivalent is being processed by Wise out of every $40 that are being moved in the world. So it means this stat is from a couple of years ago. It has grown ever since, but our public relations team are slow to update our public stats. So this number is actually bigger, but it means that our global ownership of the market is about 2.5%. And in any industry or any sector in the world, when you start to measure your split of the market in single-digit percent, because the competition is very high, it means that this is quite awesome result. It means that you are quite significant in this industry, and this company was founded by Estonians. Most of it has been created and developed in Estonia, so I'm really proud of that, and it's great that we managed to develop one of global unicorns from here, from Estonia. But still, we have a lot space where to grow, because we can tackle the rest of 97.5% of the consumer market, and even more in the business international remittance market. Talking about businesses, today we are also not just a financial service, so we are clearly a financial technology company, and so right now, a lot of big banks in the world and big tech giants like Google are starting to use more and more our APIs and our technology, because nowadays companies from pretty much any industry and any field are implementing some financial features on a global level in their products. So last summer, I was invited to speak at this conference. It was later actually postponed, but I felt I want to go to Tartu. It will be awesome to present here. But then I started to think, what am I going to talk about? And I checked out the agenda. There were already some submitted topics. Everything seemed quite interesting. And around the same time, I was checking out some stats about Wise, about our technology, about our organization, and I realized that we reached the point where we had more microservices than we had engineers at that point. So who is working with microservices here? Please raise your hand. Yeah, this is a normal status quo. Everyone these days are working with microservices, but just in case, because not everyone raised their hands, and today there were some presentations about microservices, so probably you know it already, but just in case you don't know, quick reminder, so usually companies, when they start building their product, they just start with one application. Then at some point, this application becomes too big and teams are too slow to release new features. It becomes uncomfortable to develop everything in one single mono application, so they start splitting some pieces off, and they start developing new pieces outside, so in other applications which all speak to each other. And usually these applications also have different ways of storing the information, databases, and in addition to synchronous communication between each other, they also talk to each other asynchronously by sending messages where you have always guarantee that whether the receiving service is up or not up, eventually they will receive your message. So this is the asynchronous messaging, and usually message brokers take care of that. So, and at some point, your architecture is growing, you get more and more microservices, databases, and at some point, one team is not enough to maintain all of that, so you need to define what teams you will have. So let's imagine that we have a little startup with 5 teams, and at some point you decide that your service boundaries will be defining the boundaries between teams. So you are strict with yourself and you take a decision that every service that you have in the system will only have one owning team and no split ownership, because this way the development and the ownership of if something like breaks is always crystal clear. So today in Wise, if we were to draw the service diagram of all of our services, we would need 32 pictures like that. Here on this picture we have 18 services, which means that we have today 592 microservices or deployable client apps. 540 of them are on backend, so then we have about 50 micro frontends and 4 mobile apps. And all that is being developed by 579 engineers. So it's roughly the same amount of people that we have here as visitors on this conference. So it's a large organization. And these people work in 98 teams, and we do 4,500 releases a month, which means that about 150 times a day we release some new features or updates to our customers. And then simple math, if we take a look at number of microservices and engineers, we have less than 6 people in each team, which I think is a good metric. Like usually they say that for optimal team size, you want one team to be able to eat one pizza, so check. We have about 6 services per team in terms of the ownership, which means that out of all of this technological pie that we have, each team is owning actually quite a small split. And yeah, each team usually is doing more than one release per day. And soon I will explain why these metrics are important. So also, of course, in order to achieve this 150 releases per day to the customer, you either need to have a continuous delivery, which I, in financial service, wouldn't prefer to have. I like when releases are supervised by engineers. So we have given all engineers in the company direct access to release their features to production. So we built a proprietary system for that, and they only have access to those 6 services on the average that their team owns. So this way, we ensured that the speed of the delivery of features and updates to customers is high. And for the size of the company, where we can measure our engineers in hundreds, it's actually quite a good result. So most companies, when they start developing their system, they start with a monolith. Many really smart people have said that this is always the right decision, because as you develop the monolith, you become to understand what are the right domain contexts and boundaries between features before you eventually split them off. So in our case, in case of Wise, the start was relatively slow. So for the first 3 years, we were just living in single monolithic application. It was written in Rails. Only 3 years later, we decided to split it. We decided to split it because we felt that the cadence of releasing changes for our back office and back office tooling for operations and for customers was different, so we wanted to split these things. Then a year later, we decoupled front end. So this is what many startups eventually do as well. So now you have a very clear boundary between your back end and front end. And then the time was right to start investing into the decoupling of the business logic and making the architecture distributed. So in the next couple of years, we moved from 2 microservices to 80, then we moved to 400, and now we are at roughly 600. So if you look at stories of many successful, quickly growing startups, the pattern is always very similar. So there is nothing like unique about WISE in that terms. But engineering in our company is only 20% of the employees that we have. So in total, we have 3,000 employees, most of them working from, or like the biggest office that we have is in Tallinn. So maybe we can also cover in few brief words principles about how startups operate. Again, I think that by now there is very clear common pattern. Most of successful companies in the world that grow quickly actually operate in a very similar fashion. So here's the recommendation from Bill Gates for you. Measure What Matters by John Doerr. Who has read it? Few hands. I haven't, but I know what's written there because simply like startups and successful companies like really operate in a similar fashion. It's very data-driven, KPI-driven, and I feel that in today's world, the data is the king. So these days, in my opinion, data analysts and data scientists especially are the kings of the kings, because today their models and they decide who will win the presidential election. They will decide how long you will be scrolling your TikTok tomorrow, and they decide, and the result of their work decides how quickly different companies are gaining the momentum and gaining their customer numbers. So, the modern successful companies just simply need to invest in machine learning and in their data warehouses and in their data analysts and scientists. So at some point, I clearly came to realization that, like, for me, data people are like the most significant people in-house. I want them to be as close as possible to product engineers and product managers. And then obviously, if you develop your company in extremely data-driven way, then you become extremely obsessed about the observability stack, about monitoring, about understanding everything in terms of like your technical performance, your product performance. So you just start to live in this world of data, but this eventually pays off. And of course, you invest a lot in the automation, in automating the continuous like testing of your system in pre-production, in production. So today, like many robots are like every hour doing tens and tens of payments in WISE in production, because this is like the way how we can ensure that it will be then working for our customers as well. And one thing that I wanted to talk about is that at some point, as we were moving in a very data-driven way, we were really we learned how to predict what we will deliver, what will be its impact, and when we will deliver it. So we decided to make all of our plans public and start talking about everything at least 3 months ahead to our customers through our public channels. So the first thing that we launched was the mission roadmap, where you can go and you can go to wise.com/mission roadmap. You can filter by regions, and we actually like brag and like show off to customers what they can expect, and it is filterable by types of the product lines that we have. So this is also making us very disciplined and deliver to customers what we actually promise, because once we have announced it, we need to deliver it. Second thing is making summaries about product updates that we ship. So again, once per quarter, we publish a full list of all new features, all new regions, everything that we have launched. This is also like keeping us disciplined and focused on always making sure that by the time when we publish those results, we actually deliver those things that we wanted. So of course, for that, you need to have a really fast organization. And this is what can go wrong when you are growing your company from 10 to 15 to 500 people. So many companies have learned that. There are also like many studies, because there are very many companies which are of our size, right? A lot of companies have faced very similar difficulties. They have faced very similar patterns of problems. So you can probably like read a gazillion of books about that. But it's very clear that running a 50 people company is very different from running a 10 people company. Running 500 people company is very different from running a 100 people company, and running 3,000 people company is different from running 500 people company. So it's very easy to get lost in that. And in my opinion, the biggest risk for startup is as you go big and as you grow is that you become corporate, you become slow. There are hundreds of people that you depend on and depend on you. So like obviously it changes and it doesn't feel like a startup anymore. And if it doesn't feel like a startup anymore, then it breaks your culture. And when it breaks your culture, then it's really sad. So I think like the art of this situation is trying to maintain this speed and the sense of being in, if not in startup, then in scale up. And as we were, growing from like 50 to 500 engineers, I have like really warm and interesting memories about at some point realizing that, hey, software engineering is actually the simplest type of job that you can monitor and track in terms of performance, because engineers are doing everything on the computer. So you can track every single line of code that they push. When do they push it? When do they commit it? When it's being reviewed? When it's being merged? When it's being built? When it's actually out there and being used by customers? So like all the life cycle of the daily work of engineer, of like all of those 100 engineers, you can observe that from the bird's view, and then you can see different patterns and you can understand what works and what doesn't work. So we developed a special engine in our data warehouse, which was tracking, which was collecting, like in product, companies are collecting stats from their users. So we started collecting stats from our engineers to understand in a data-driven what is happening in the company and not lose sight. And then we realized what we need to track and what is actually important as you grow. So like one of the first things that we started monitoring was obviously trying to understand how is the system architecture decoupling going. So how are you decomposing your archaic monolith into a nice and effective microservice architecture. So this knowledge about how is it going is not very important, but just having this visibility on this data, again, keeps you disciplined and motivates you to see the result of the decomposition. Because like many companies actually at some point decide that, okay, we will invest in the microservice architecture, but they do nothing about actually tracking how it's going. So by simply being able to monitor and observe that will show to you how well your technical organization is fulfilling this goal. And around the same time when we developed this data collection system about the work of engineers, we also created the engineering experience team. So meet Mallory. I have like really warm memories because she was doing the qualitative analysis and development in Wise. Later, she was working at Salv. I know there are probably many people from Salv in this room as well, so you know her. But like she had, I think, some sort of degree in psychology, so she was a really good psychologist. So in addition, for us measuring and collecting the data in automated way, she started doing hundreds of interviews inside of the company and putting together those mind maps and explaining to us what this data that we are collecting actually means. And then we were able to find patterns and correlation between what she was telling us about the happiness and satisfaction of different teams and what we were seeing in the data. So very quickly, it was clear to us that lead time is one of crucial metrics for a growing organization. So lead time is the time from engineer starting to work on something and this something being fully released and functioning in production. So you want to have this time as short as possible. And when you start working on a small startup, when you have a small team, obviously you ship things fast. Your code base is not very complex and it's small, but as your architecture and as your teams are growing, most likely your lead time per engineer, per feature will start to slow down. And you want to do everything possible to avoid that happening. And then we found very clear correlation between the satisfaction and happiness of engineers in team and the average lead time that their teams have. And for me, that was really interesting insight, because I was feeling that if we were investing in improving the lead time and keeping it as short as possible, we will be shipping things to customers much faster, and as a byproduct, we will have happier and more satisfied engineers, because engineers are creators. They want to build things, they want to be able to ship fast, then they feel not constrained. They don't want to feel that they need to jump through corporate loops to ship anything or get anything done. So because of that, the lead time became our North Star KPI with this data collection model. So quick summary, lead time equals engineer happiness. And you can look at lead time, for example, from a DevOps perspective. So you will see that lead time affects the deployment frequency. To reduce the lead time, we reduce different wasteful activities, which in turn lets us deploy more frequently. And then deployment frequency speed helps and is achieved by different improvement of practices and automation. And then the speed of recovery from failures is improved by better practices, automation, and monitoring, which means that companies are able to recover much quicker if something goes wrong in the production. So this, like, I like to imagine that if you have a naturally aspirated engine and this is your team, then you put a turbocharger on it and the same engine starts to work in a much more powerful way. So the power of output is bigger. So putting a focus on lead time is actually like helping to build the supercharged teams. And let's talk about a few metrics that we were tracking. Many of them will be obvious, but I remember for me it was really insightful and satisfying to actually see that they actually matter in real life. So the first thing that we saw in terms of the lead time is that development in bigger services is significantly slower than in smaller services. So by trying to manipulate how many lines of code each team owns and how many services they own, if you reduce that, you will eventually see that your teams will start shipping things faster. Next thing, which is again very obvious, but it was really nice to actually have a proof in data about that, is that cross-team collaboration is much slower than doing something in your own code base. Because on a cross-team level, most likely you are working with the code base that you are not familiar with, and you also need to get the review approval from another team. Cross-team communication is always smaller, so if you want to improve the lead time, then you need to manipulate somehow how much this cross-team collaboration is happening, which means how much different teams depend on each other to ship their features, and you need to get that to minimum. Then also, I think, obviously at some point when you have hundreds of microservices, some of these microservices will become new monoliths. So you also want to track how quickly your services are growing so that new monoliths are not like being created, so that you start decomposing them before they become a problem. And then, of course, thinking about the cross-team development, you want to see which services are getting most of the contributions, because if it's the service of some team, probably it is leading to this service to grow too quickly. And if it's happening on a cross-team level, then it's a very clear and red flag that most likely feature development around that code base will be slow. Also, just like being able to track how big services are, and if you do it in an effortless manner, if you just like build it all into nice and easy to read dashboards, then it will motivate you to clean up the code base and remove outdated chunks of code, and most likely avoid having too much craft or the technical depth. Then again, a lot of very insightful information was about analyzing deeply the performance of PRs, because different teams perform differently. So we were seeing like very clear patterns that some teams' PRs are small and quick. The smaller they are, the quicker they usually are reviewed and then released to the customer. And for example, the amount of comments. So if we were seeing that some teams were commenting their PRs way too much, then probably it means that there are disputes about the implementation, which means that the preparation work before starting to develop was not good enough, which means that we are shipping things slowly to customers. And of course, if you have a lot of disputes in the team, it means that you have unhappy engineers. And of course, then to put a big dot on that topic, we've been analyzing the speed of releases, the count of releases, and we knew that if the number of releases is high, then it means that we are shipping features quickly to customers. All right, finally ended with this topic, and I have a few more things that I wanted to talk about. It's about what sort of teams start to emerge when you move into the territory of hundreds of engineers. Because before that, most likely the majority of teams that you have are vertical. It means that they work on their narrow vertical, maybe developing some specific features, or maybe working on some region, or working on some specific product. So we can call them product teams. But usually, sooner or later, companies start to identify that there are some certain things which all teams need equally. And then you start developing those horizontal teams. Usually one of the first one is, for example, DBAs and the infra, the guys who work on the delivery pipeline and maintain, I don't know, your Kubernetes clusters, so the infrastructure team. But this is quite boring example. As you move forward, there are more interesting examples that start to pop up. Based on our experience, for example, we have a machine learning platform team, or for example, real-time data platform, or DB engineering. And these horizontal topics are, in my opinion, extremely complicated. They require a lot of deep knowledge, and it wouldn't make sense for all of these vertical product teams to actually have expertise in that. So they want to consume and apply all that complexity without being proficient in that underlying complexity. So in Wise, every team has a mission statement and the statement of the reason to exist. For example, I took this from real-time data team. They deal with data aggregation and streaming and the processing tools for big data. So they enable Wise to process data in real time in a scalable, reliable, secure, cost-effective, easy, and convenient way. And they build a self-service platform anticipating the needs of product teams. So the keyword here is self-service platform. So at some point when the organization grows big, it makes sense to invest in developing those self-service platforms. So you basically have those software as a service or domain as a service teams within your organization, which are very knowledgeable in some domain, and they develop the tooling for everyone. And one of my favorite examples is machine learning, because I see that it plays more and more important role in the success of different features. More and more product teams and, I don't know, any teams that deal with, for example, money laundering or financial crime. So any domain in Wise, they can benefit from applying those machine learning workflows. So it would be such a waste of time if all of them had to actually go and figure out how to apply machine learning. So because of that, we have this platform team, and they develop all those tools and guides, and they train those teams how to adapt it quickly. So today, any of our teams can just deploy a machine learning workflow in a day to production without any prior machine learning experience. I haven't seen this being done in a day, but one of my teams was able to actually get to production in less than a week, and I saw that, wow, that's actually quite amazing. So, and I haven't touched it myself, but I went and checked out how it works. So yeah, you have guides, you have libraries, you have SDKs, so you have a step-by-step guide how to actually get it out. And I think that as you grow, it really empowers your teams because they don't need to deal with that complexity. They get it for free and they don't spend time on that. But they benefit from having access to that and delivering it to their customers. So that's it from me. Completely random memories about this journey that I thought were related to this data-driven model that we have. And we have several technical blogs all over the internet. I don't know why. One of them is in Medium. This is where I'm writing my posts. So if you want to learn more about the technical philosophy of WISE, please go to medium.com/TransferWise Engineering and read more. Thank you for your attention.